So yeah, welcome everyone to the next latest and hopefully greatest iteration of the AGI discussion forum. And today we have Doug Miles talking about Logicmoo, and he will tell us. Everyone who's too young to know what a moo is, Doug will explain it. And I've encountered Doug Miles' work indirectly a number of years ago when I was working with David Hansen on some robot control software David had sitting around a long time, and there was a bunch of logic engine-y stuff in there which was attributed to a mysterious entity named Douglas Miles. So I'd sort of seen there was someone else who liked logic doing stuff on the back end of some of the Hansen robots, and then sometime later intersected Doug online more directly. And Doug, it's been great to have your contributions in the AGI discussion forums. So far, poking around the Logicmoo website, I could actually, in Codebase, I could see actually a lot of stuff, spiritually at least, and in some ways concretely related to things we're looking at in the Proto-AGI project with OpenCog now. Some things we're thinking about with the SingularityNet metaverse in terms of work my own team will do in the future, sort of looking at temporal reasoning, how temporal reasoning embedded into richer logic engine with an appropriate ontology can guide sort of simple forms of language associated embodied learning and move you toward AGI that way, potentially. So Douglas has been playing around in this space for quite some time, like myself and many others. He's got some unique insights and approaches, for example, related to the role that narrative plays in all this. So yeah, I thought it would be great to let Doug talk a bit about what he's doing with Logicmoo, what the ambitions and the achievements and core ideas are, and then have some discussion afterwards. So yeah, with that, take it away, Doug.
All right, thank you. Yeah, thank you so much, Ben, for letting me do this talk today. And so yeah, I started working with David Hansen probably about 2008 or so, and we worked on a few robots. Bina 48 was the robot I probably wrote the most software for, and at the time she was going to be a narrative AI system, but we just didn't quite have the time. David was really good at advertising, and so we were always getting ready for a demo. Like, okay, he would say something like, we're going to be on TV in 2 days or whatever, and I had to have 2 days to sort of work on the system, and you kind of have to freeze the robot at that point because you don't want to make too many changes at the last minute that you don't, need. So that must be kind of fun because Ben's been working for David Hansen too quite a bit, and
Hansen Robotics still has some similar characteristics to what you described. Yeah, what you've just noted, there's some resemblance to our recent work with the Grace robot. Actually, yeah. I mean, there's still a ongoing, interesting dialectic between making exciting stuff to show off and getting the fundamental development done to really move toward an intelligent system. I think now there's more resources around than you had in the old days when you were working with David. And technology lets things go a bit faster, but that dialectic, if we call it that, certainly still characterizes this sort of work.
Yeah, it's really a compliment to him that he can get stuff promoted kind of so quickly and people interested so quickly. Logicmoo is created to address. So initially, everyone has been thinking that if they could solve a certain set of problems, they would. An arbitrary learning system was to solve a certain set of problems, so it would somehow emerge consciousness. So the task was to define human hard problems where the most optimal answers, great human-like methods, may be based on consciousness. So, for example, well, here's the thing. This is not quite based on consciousness. This is just based on solving problems. But the idea is that probably consciousness would emerge if the problems were so hard they required consciousness. And so is the scaling hypothesis. So if you were to put a certain type of neural system and learning algorithms against diverse experiences, if those experiences are diverse enough and the net is able to fit properly enough between instances or problems, whatever generality that exists between the problems would somehow get stored into the program. And all the cases that those generalities would not quite fit through easy means, a more complicated system would arise to make it still work. For example, it might manifest an internal dialogue of some sort if that was required to do that type of thinking. Problem is, though, is that human-like methods based on consciousness are not always the most optimal algorithm to solve a problem. So, for example, a sorting algorithm could be done quite simply in code, and that's very optimal. But if the human was to be put to the task, or human-like methods of comparison and a human, I guess a good example, let's say the human way of doing something was bubble sort, and then you were to compare it with Q sort is going to be better. So a system that's searching for optimal solutions will probably find Q sort, therefore skipping over the human method. And that's just intrinsic to it. But still, everyone, and I guess even in OpenCog right now, so what I'm saying here is that, if we're trying to write an algorithm that, if we're trying to discover consciousness by trying to solve a hard problem, we might end up just solving the problem and merging them. Here. Trying to define a hard problem within a virtual world, so that way our system will try to do something and end up manifesting human traits. Okay, so another approach to AI, or actually AGI, is to go through some sort of evolutionary process where we start out with a simple program and several simple programs, and eventually when combined together, they merge into the complex behavior that we're looking for. We kind of feel like humans might be based on this sort of design, but we think it came from a very, simple animals without much reasoning ability, probably without consciousness, that have emerged all the way to human by upscaling by having Mother Nature upscale the simple animals into the level that we now have as being the human being. So where to start with our evolutionary path would be something like an ant. And so let's look at what Darwin says about ants. Okay, so first he wants to say that a few people dispute that animals possess reasoning. But here's what he says about ants. Insects play together. They chase each other. They pretend to bite each other. When ants have been separated for a while, when they reunite, they will caress each other. And in battle, if they accidentally attack one of the friendly ants, they will perceive their mistake, and one ant will soothe the other ant. Definitely, animals have been constantly seen to pause, deliberate, and resolve. So what it's starting to sound like is Darwin feels like animals are conscious. I mean, if they are actually deliberating and not just reacting with stimulus response. In fact, he says that he finds that many animals exhibit different levels of self-awareness. So Darwin says that animals are already conscious. It sounds almost like human level consciousness. If we're to believe Darwin about this, it's probably vital that we made something self-aware. No one really feels like they know the basic elements of consciousness, not even for an ant. It's more comfortable to know things like mathematics, evolution, logic, machine learning, neurochemistry. So we think if we study these things, we are going to be able to manifest or create the conditions in which we can create AGI. But I'm not sure, I don't believe this is true. I think we actually have to have a target, and we have to presume at least some sort of psychological model. And but anyone that would claim to know how humans think would assume to be what? A psychologist. So, for example, Roger Schenck, a psychologist, has something called conceptual dependency theory. Before I move on, I want to go back to something I call the new paradigm. And I think Ben has endorsed this method. Yeah, I think I kind of got it from Ben. I mean, so the creation of trying to create a problem hard enough that would create AGI, I'm calling the old paradigm. New paradigm is, how do we write a program that will have human capabilities with the guidance of intelligent caretakers? And I think that is a great goal, but I don't want to expect that we could be able to do that without at least having some sort of an ant level intelligence. And in order to have that intelligence, we're going to have to assume that we know something about consciousness. So looking to the psychologist Roger Schenck, he has this theory, and I don't think this theory actually creates consciousness, but a couple slides from now, I will explain how someone did think that consciousness could be created out of Schenck's theory, which I happen to agree with. Eric is that person. Okay, so conceptual dependency was originally designed for translation of natural language into a logical form that would, without loss, be able to give the information and convey the information. And this is an event calculus formation, which means that there are causal relationships between this. When this happens, something else happens, and but it's an event calculus that's very logical and capable of holding meaning and connecting these together. So, like the typical example is John goes to a restaurant, orders food, and then he's washing dishes. The system could infer that he maybe lost his wallet on the way to the restaurant, and it constructs an entire internal story about those things. So then when you were to ask it questions later, it was able to, if you said, why did John wash the dishes? It could say, well, because he lost his wallet. How did he lose his wallet? Well, on the way to the restaurant, he must have dropped it someplace, or maybe a thief had stolen it. But then it also can infer that if the thief had stolen it, John would know he had no money, and he probably had never gone to the restaurant. Okay. So anyway, this is about logic and not so much about conceptual dependency theory. So I said a moment ago that we would, that someone thought they could turn Schenck's system into something that was potentially able to be conscious. And the way Eric did this was he has a system that daydreams, and in order to daydream, it has to use a little bit of self-narration. So the daydreams the system has are daydreams that the system is forced upon itself. It starts out with goals and motivations, like it wants to be in a romantic relationship, it wants to be entertained. Right now it can't be in a romantic relationship, so to get entertained, it goes to a movie theater. While at the movie theater, it sees Harrison Ford. Harrison Ford realizes that she's not well dressed, and he doesn't want to get into a romantic relationship with her. Also, he's possibly married. But anyway, she's very unhappy about this, and so she ends up. It's not written on this page, but like in a couple other examples, is that she feels a little bit angry. She goes home, changes her clothes, comes and tries to flirt with Harrison Ford again. This time he wants to go out with her, but she's still a little bit angry from being snubbed the first time, so she tells him that she won't go back out with. She's not interested this way. And the way the system works is it's motivated by how it's internally feeling. Like, so in the first case, she wanted to date Harrison Ford, and he said no, it hurt her feelings. So she had to imagine a scenario that she could get back at him, rather than necessarily putting on a nice dress, meeting him, and having a romantic relationship. She's felt more inclined for that revenge, and because that was supposed to cover the negative emotions she felt in her first failure. And the system, when put in different scenarios, acts very human. And it does so through this complex decision tree that it's always got running. And by having that very strong initial setup, it's able to, or actually, let's say, despite that, it's still able to act pretty well accordingly. So the positives about Daydreamer is it uses both symbolic and stochastic reasoning. The event calculus of Schenck is really good for action mutation and so forth. And the actual language is great for creating an imaginary buffer. And it's good for hierarchical planning. Now, downside of the system is our example was extremely contrived. It doesn't really account for how the system learns. And it's not detailed enough. Like, it's not dealing with sensory I/O, and that's probably some of the things we're interested in. We're interested in scaling to the world level. We're going to skip the natural language aspect of Schenck's system. So, Schenck and Mueller's system, they're generally just a bit too high level. They look like, they were contrived demos that were cooked up. And so, but something interesting about Schenck and Mueller, the work, is even though they never created AI or AGI for us, they showed us what it would look like in a way from the point of view of the internal dialogue that someone, or would have. So it's a great example of, if you created AI, this is what it would look like, rather than trying to make your judgments in other ways. They're saying, if we had a mind, this is what thinking would look like. So just wanted to express that. So here, next part slide here is going to show where we apply conceptual dependency theory and a little bit of Eric Mueller's ideas to take the IKEA test in a certain way. And so I'll play the slide. And we can already see that this would be a great system for implementing animal instinct. It might even be able to do stuff with like an IKEA test, as long as the test was written in Shank's method. So for a spider to be able to be born knowing how to build a web, he would have an instruction book written in CD script. That's Shank's conceptual dependency script. And so spider would have instructions on, like, say, how to build a web in this language. But in Logicmoo, we said that's probably not good enough because those instructions are probably too specific. Okay, so how this actually works is there's a virtual spider building a web along with the real spider. We had to do it this way because the virtual spider has a very different world than the actual real spider. But the real spider is trying to map as much analogy between the two. And the way the analogy is made is patented, patent pending. I did the provisional patent so far. The imagined spider is only going as far along in the imagination world as a real spider is in the real world as far as how much of the web is built. And there's just different stochastic clues that go on between the two. But we have to, before I start, we have to explain how the spider actually gets to the motivation to build the web, and that is because the virtual spider is going on anyway, even without the spider initially starting to build the web. And the spider is looking at the internal world, which has a web being built, and it's different than the external world. And so how Logicmoo works is we get motivation as where you're trying to copy the narrative that is going on in your virtual. So what's happening is, so in the scenario I'm trying to describe here, is that we have a spider I'm calling it the real world, but really it's going to be 2 virtual worlds or 5 virtual worlds. But whatever the world that we humans are hanging out with the spider in is the world that doesn't already have a web. He or she is imagining a world with a web existing, and over and over in its imagination space, it's seeing this web built in the world. Well, this causes a little bit of cognitive discord, dissonance, because the spider's seeing a difference between its imaginary world and the actual world. And so this bugs the spider, to the point where the spider is now motivated to put the web in the real world. What this is about is trying to find a motivational system that's not always based on some sort of reinforcement, because we see it all over the animal kingdom. Animals are doing things that seem to have no reward, and they're definitely not everything an animal does is individually rewarding, and the amount of time it might take between the action and the reward is so far distant that we wouldn't imagine the cognition being there for the animal. So the point was to establish at least some kind of element that would move a creature into doing things like this. And what was difficult was, like, using something other than, like, say, a brute force planning system, because we've got a couple problems with that. Is it's not going to be as detailed and scale to the types of to the real world. It just doesn't. The amount. So hopefully I make the point here in this next part of the slide that I'm about to make verbally. Hopefully, virtual world, it tries to get the real world to be following the same narrative as it's virtual. So the spider keeps being shown the same images over and over until finally it starts to realize that its real world is not actually in harmony with its mental world. And so when the cognitive dissonance is so great that the spider's not happy in the real world, it starts following along the spider in the virtual world and tries to build a web. So when the virtual spider has an instruction booklet, and in that booklet, It's false. Okay, yeah. So what's going on here is we are taking the IKEA test, but we're taking it inside a virtual world in a contrived situation that it's always going to succeed. And then we've got the spider on the real spider on the outside in a world that looks nothing like the IKEA test. And as that's taking place, the amount of mapping, you're not going to be able to map that real world into the virtual world, but you are easily going to map the virtual world into the real world. We're going to we have an analogy system that uses where it actually creates two virtual worlds at this point. So we were at real world, virtual world. Now we have two more virtual worlds here. That the narrative, an internal narrative is playing into the virtual world number one, and also playing into virtual world number two. The real world is being superimposed into virtual world number three here, and we're getting a differential. But the only amount of real world that we're actually looking for is the amount that we already see in the virtual world. So, for example, if everything you're looking at in your visual spectrum, well, your visual spectrum can have, you could be looking at the moon, let's say, or Mars, and in your virtual world there should be all these lines on Mars. You're going to probably see those lines in the real world. Your eyes are only going to show you what your imagination is available to show you. So what we're leveraging here is that rather than trying to scale the real world into something that we can sense, what we're really trying to do is scale our virtual world into something that looks close to the real world. So we're so in this sense, this is what's going on here in the slides. And so there's this instruction book that the virtual agent is using, but not our little AI guy robot in the world. Going along, it's virtual world and everything's going great because it's virtual world, and the instruction booklet are perfectly aligned. But the real world is never that perfect. Anyway, so the spider starts to do at least the initial things that the virtual spider is doing, and that is just letting some web blow out in the wind, and I'll go into every little detail, but his actually most spiders are female. I think process my explanation and imposing on for about 5 minutes, possibly happening, and so on and so forth. Through a certain process, a web gets built. Through a certain process, a web gets built. That's possibly happening all out throughout, the spider kingdom at least. No, excuse me. I believe this is happening throughout the entire animal kingdom, that many, including humans. We'll hopefully get into human proto-narratives as well. The proto-narrative system is I'm going to cut this part, but okay, why the animals are pretty good at mimicking, and so the proto-narrative system is a system to create something for animals to mimic. That since we already know that we and animals have the ability to copy what we see, our parents or whatever, we have this virtual agent that is a proxy for us, the animal to mimic. And humans are good at that too. And but what we're doing here is we're setting up an experiment to where we're finding out if instincts could be done through this proto-narrative visualization. So this makes the experiment was a success. That there's not enough choices in small decisions, the type of small decisions that we assume simple creatures make, that would actually emerge an entire spider web. There's got to be these larger things that in time scale that take place that are outside the immediate condition response or stimulus response purview. Okay. So we think this happens throughout the animal kingdom. For example, a beaver, when they exist in the world, they have the same sort of their virtual. Basically, say that dams and spider webs are kind of like the same thing. Can be kind of high, especially with all the different modalities. But mapping your virtual world onto your real world, much lower bandwidth, like full world, because it maps as closely to the real world at runtime as possible. and it doesn't ever extend out beyond its normal set of proto-narratives when it's doing that mapping, so it stays very scalable CPU-wise. So Beaver builds the dam through the same process as the spider benefits, and it was really a good idea. Ideally, if there are benefits to the animal, and the animal gets some sort of a actual reward, like say some fish, the beaver feels like that was a result of following the proto-narrative. And that makes, so what I'm trying to say is, if there's any the type of reinforcement that's going on is the instinctual proto-narrative action is more likely to listen to that momentary virtual beaver or watch that virtual beaver and continue trying to map some of those same behaviors onto my virtual beaver, my inner beaver. The proto-narratives exist all over the animal kingdom. Especially the more higher the animal is, the more complex their proto-narratives can be. They cover things like reproduction, chewing food. They actually cover learning, and I'll talk a little bit about how learning is done using the proto-narrative system. A lot of the proto-narratives are easier to express in sensory data, and how that sensory data arrives is through the cheap process of CD scripts. So CD scripts play into through a system which appears within the animal's imagination. After we've done one of these things, we actually feel that we did it. We don't imagine that we don't specifically have to imagine it was someone showing us something. We just feel like we did it. So they were having a hard time getting pandas to breed in captivity, and the pandas just weren't very inspired. So they thought, well, what we ought to do is make some videos to show pandas breeding, and so that they could mimic what they were seeing. So they created some panda porn. And here's a picture of a panda here watching panda porn. These are actually humans in costumes pretending to have sex, and it may or may not be how pandas normally do it. But this panda, you can see is getting very excited by watching panda porn. So Logicmoo has to store things it learns and so forth, and access its proto-narratives through a special system. It does this through a system called call response. So instead of stimulus response, we're using call response. Call response does all the same things stimulus response does, except it allows consciousness to be part of the process, and it's used for recall of memory, memory recall, and so forth. And there's a lot of neuroscience behind call response. And throughout time, we've used poetry, music, even mathematics is done through a call response system. I'll show you a paper that neuroscientists had created about the call and response of mathematics. Initially, though, it was important to have a system that was efficient at storing and recalling very complex narratives in the event calculus. And in order to, so one of the problems with Eric Mueller's system and event calculus in general is it's not ideal for storing facts. Like if it wanted to remember who the president of the United States would be, it might have to actually play through an event calculus that would get someone elected, and that would be terrible to remember. So like if when a teacher has students in the classroom that won't focus because they're busy doing their proto-narratives of whatever that will be, teacher will say something like hocus pocus, and then the students have to say back to everyone focus. And people are able to use this sort of poetic way of doing things, and it really on a low level is attached to human neural wiring to do this call response. Terrible explanation of this slide, but that's okay. Thousands of years ago, the Greeks thought there was a thing called the poetic structure to all sorts of logic. Well, it turns out neuroscientists have discovered, or at least a few of them have, that the poetics of argumentation is actually possibly how we do mathematical reasoning. So one other aspect of call responses is really good for teaching people things and for brainwashing and so forth. So I have a couple of papers up on the website about this, and I have some examples where we have training to teach the system through mathematics and arithmetic through this call response system. So, at the very minimum, I think an AGI system would at least need to implement a working proto-narrative system, Logicmoo's patented proto-imagination system, the encoding of mathematics through the poetic reasoning, and the call response system. But there's a lot more here. The way we do learning is through a process similar to world building, but except into a mind palace, and which is it's a system of call response, and also since call response is used to remember events like who is the current president and so forth, we can scratch off that in a way that we're working. We've sort of dealt with one of the Mueller-Shank system shortcomings here. So let's cross that out. And now, okay, the complaint that their system is too high, or you can complain that my system's too high level or contrived. The way that's worked through is that when a proto-narrative is played onto the imagination, it actually is very contrived, right? The real world is never as pure as the virtual world, but we're looking through our eyes right now at the virtual world. And if we do a good job at imposing our virtual world into the real world, actually, I should say that we have, before I get into predictive coding, three types of buffers. One plays a CD script, which we're calling mentalese here, and another is dealing with the sensory world, which plays its own CD script, and they both play into the same buffer, and a differential takes place. This is a patented part here through this four-layer system. It's almost like V1 through V4 to get a differential. And the differential contains a set of CD script or proto language that is used for actual memory storage. So you don't actually store all the details, you only store the differentials. So I was saying proto-narratives are connected through CR coding, call and response coding, and poetic reasoning. They are a little bit stochastic in how they connect up, but when you're born, they're connected at least mostly, and they've been over evolutionary time been better honed to be connected correctly. And so when an animal follows a proto-narrative, they end up experiencing less discord. The motivation system used in Logicmoo is how tightly the proto-narrative works out. And when it does, there's a little bit of reinforcement. In a way, you could see that almost as evolutionary time predictive coding. Usually predictive coding is about an animal making sensory predictions. If you can keep these mapped as closely as possible to the real world, and your proto-narrative here is actually your diff script, not the actual proto-script. Your diff scripts, as you're learning, your diff scripts between the before and now have their own specific rule system that you're building stochastically as you're going. Anyway, this is our model in which we are doing some predictive coding. So usually predictive coding is about trying to predict the next state of the environment, like what you should be sensing. But we don't actually expect that everything is predicted here. Or what a lot of things are actually forced into the visual buffer or all the buffers, all the sensory buffers. Okay, that's kind of that was a long sort of explanation about proto-narratives and predictive coding, which a lot of neuroscientists find exciting. I don't really, but I felt like I had to at least talk about it a little bit. I think what's more interesting is the idea of parsimony in Logicmoo coding. If you had to remember a list of dairy items that you were going to go to the store to get, say milk, butter, and eggs, they're all generally stored in the same area of the shopping center. So instead of remembering the individual items that you're after, instead you remember just to go to that section. And when you get there, with a little bit of chaining, you'll have all the details. And this is the idea of parsimony in the system. So when the system's trying to record some piece of a narrative, it only has to store enough of the narrative to get to the point where it is going to begin forward chaining out the rest of the narrative as it gets there. So the idea is that we're storing a little bit less, and also that we can make better differentials between things. That's important to know, but I think maybe what's more important to know is something that's probably more important is the discussion of the architecture of Logicmoo than the psychological data and stuff. So Logicmoo is based on this concept of a prologue mud, and a prologue mud is a type of mud that is written in Prolog, of course, that does a lot of forward chaining to determine the state of the world, and this happens automatically. So what's really important in Logicmoo is I've been talking about these narratives and proto-narratives and so forth, but what's important about these is they play into an actual simulator. And the simulator is very lightweight because it only simulates the event calculus, not the actual physical world, not the visual world, not the audio world. It only simulates the conceptual world. So if you were to declare that in your world you have a toilet and it flushes and sometimes it gets clogged, that's all. Just from that little description, I know that our minds have created something that looks like a toilet, but Logicmoo doesn't have to do that. It just has to have the concept, the word, the symbol, or whatever. And it knows that there's an action that can be performed on it, and it knows that sometimes as a result of this action, something happens, like an overflowing happens. It doesn't know what overflowing is. It doesn't actually need to ground a lot of this information. All it needs to do is simulate the event calculus of the situation. So how this happens is in several instances or forks of a mud. So by the way, this is like compatible probably with Atom Space as far as a knowledge representation. It doesn't need to use the stochastic floating confidence truth values that Atom Space uses. It's pretty much just it just uses logic, but it's still representable in that space, or in Atom Space. So with an assertion, I mean, I should probably show a demo. I might do that. I don't know. The complexity of the world is always hidden within the backchains of Logicmoo. So the world is only the size in which the inference engine decides to explore into. So if we had a tree that had several leaves on it and the leaves had colors and so forth, if we were to simulate these trees and branches, you're only going to simulate as much as is needed for the agent. Logicmoo, being written in Prolog, only backchains the actual results that are required at the moment they are. And so data of intense complexity can be represented in just the query that would access that data. You don't actually have to go and get the data, you just have to have the query that will give you the data. And that query, since everything is a quine in Logicmoo, a quine is where the representation of something, when you execute it, returns exactly, basically the object that, if you executed it again, it would be the same piece of code. So there's no difference between code and data usually in Prolog, and there isn't in Logicmoo. And the knowledge representation layer is effectively a quine that would get you the code that executes that layer. Simple example is the number 1. If you evaluate it, it's still number 1. If you put in source code, it's still number 1. So Logicmoo data is kept in this sort of way. So having a simulated MUD or a simulated imagination is not an expensive process, or not expensive. So in a particular context, Logicmoo could have 200 MUDs running at once, and it costs no more than a single MUD with 200 objects, because the entire MUD itself is already an object. So maybe an important piece is that the actual creation of a simulator is a dialectical process. Let there be light, let there be an ocean. And by the narration component within Logicmoo just uttering those two things, it has those two things. And the cost of them, you guys have any? I want to make sure if someone had.
The topic here that's most interesting to me, well, it's all it's all interesting, obviously, and it's all closely aligned with what I've been trying to do with AGI for a long time. I think that the aspect that you're emphasizing the most, that has gotten less emphasis in my own AGI work, is the narrative portion. And of course, this is something that's highly important to David Henson with his character AI work and so forth, right? And I think this has to do with episodic memory in humans and with this sort of social, cultural, embodied construction of episodic memory. It's something we don't have as sophisticated an approach to in OpenCog or in our current architecture for the Grace humanoid robot, as compared to, say, dealing with declarative knowledge via reasoning or dealing with perceptual knowledge via deep neural nets or something, right? Like it's clear that human episodic memory works substantially via some sort of associative memory and some like constructive associative memory. And I liked so Canerva's sparse distributed memory was an attempt to model that a long time ago, which someone whose name I always forget, a student of Stan Franklin, Javier something, implemented this in the context of Stan Franklin's LIDA cognitive architecture. But then
LIDA.
Yeah, but I forget the guy's name. He was a Portuguese or Brazilian guy working with Stan Franklin, who then went to work for Google. But his PhD was on the Canerva sparse distributed memory, sort of used as the basis for various different modules within Stan Franklin's LIDA architecture. But I mean, the sparse distributed memory had some cool properties relative to episodic memory in terms of sort of associative recall, like modeling what you do when you think, well, like what was that time when I was walking down the street with that little girl in a gray street near that big building, and then the rest of the episode floods back into your mind, right? So that's part of it. But then there's also, it's not, the episodic memory is not just a collection of unstructured like movies that happen to you or something. There's a archetypal structure to episodes, which ties in with the three-act structure of Hollywood movies. And if you look in the Dramatica software, which is both fascinating and terrifying, it's like this algorithmic software for creating Hollywood movies by like assigning, like, here's the protagonist, the protagonist mentor, the protagonist mentor's adversary. Like you assign each archetypal role to each character, and then it spits out a list of what are the key scenes. Like, here's where the protagonist mentor says something ambiguous to the protagonist. So here's where that is mentioned again in a discussion between the antagonist and their former love interest or something, right? So there's a sort of archetypal structure to episodes in human memory, which clearly comes out of our own evolution in terms of tribal society and our reproductive life cycle and so forth. So how and to what extent an AGI needs to remember things by these same archetypal patterns as people is not entirely obvious. If you're trying to make a simulated human, then perhaps you do want that, because that's how we dredge things out from our memory, often erroneously in a screwy way, right? If you're just trying to make a system that can carry out useful tasks in the world effectively, having the particular sort of archetypal narrative structure of human memory may not be important, could even be counterproductive. Like, we forget a lot of stuff, we make a lot of false memories and so forth, right? So I guess there's really two issues that I'd say we haven't fully resolved in our own work, which closely relate to what you're talking about. One is just like, what are the right algorithms and structures, learning mechanisms, retrieval mechanisms for episodic memory, for a system sort of doing stuff in the human-like world, whether or not it's trying to be exactly like a human. The second question is, what are the particularities of human episodic memory, which have to do with narrative structure as humans naturally relate to it, right? And that relates closely to the first question, but might be slightly different. Now, what's the role of logic and all that is a different question, right? Because I feel like, logic, like neural nets or something, to me, it's sort of a plumbing level tool, right? Like you could build a visual perception engine entirely in logic if you had a scalable enough hardware implementation. I mean, each pixel can be a logical atom. Why not, right? So you certainly could use logic to ground episodic memory, as you've noted. Whether it's the most convenient foundational tool to use is not entirely obvious, and something like Canarva's sparse distributed memory would be an alternative, right? It's not to say you couldn't do it using logic. You certainly could not. Prologue is a whole other thing, right? Like whether the types of inference that are needed in episodic memory are well handled via backtracking with judiciously placed cut operations is a whole other issue. And I mean, that leads us into, say, Linus Vepsva's frequently pointing out open cog space is more like data log than like prologue, right? So I mean, there are things you could do in the prologue universe that would be more episodic memory-ish, sort of moving to parallel matching, or like data log incorporating probability and fuzziness and so forth. And I guess like a probabilistic fuzzy data log spiritually is still prologue, but in actual implementation is not prologue, right?
Yeah, something interesting about associative structures is, I mean, we found out that they're very important, and we see these associations, but it would be interesting how, I mean, not in every case that we see an association is it a stochastic sort of disconnected thing that's been partially connected. A lot of times our associations are actually a larger, very rigid structure that exists, and then we decide to connect things together that way. So where I was going with that is that, I got like 3 or 4 answers for 3 or 4 questions, is that what we think is associative memory may not always be associative memory. It actually might be logically something we could have made that association with, out of. Just like if we were to go and watch a movie at a theater, and well, this is actually this was to a different question of yours. Is we all tend to see the same narratives, and I wonder if we watched 2 different movies that were basically had the same storyline, we would definitely know they were 2 different movies, but we would be using the same narrative. That's not quite actually where I was go with that. I just was going to say that, actually, let me go to the easiest question of all of them, and that's about robots and narratives. Anytime like Bina 48 was, or one of Hansen's robots was doing a demonstration, what I could always saliently say is that it had it been able to maintain 3 narratives at once, the demo would have gone really well. So the problem, like with Bina, she would get into a particular type of conversation, but she wasn't keeping along a general theme or another general theme about that. And the only way to have kept that up is to make sure that she's actually playing out 3 different narratives at once, and not just a single one that inference had told us that it was time for her to do. If we would have kept, and so I'm saying is almost every complaint that we had about our robots would have all been correctable had we been playing to more than one narrative at once. Had we actually looked at, like say, maintaining a relationship with the person she's talking to, and looking at saying, this is going to be, these are the things that are going to happen in the conversation, and so forth. So what? But on associative memory, it's interesting because we think that we're going to have a algorithms that make the event calculus work out, to make sure the planning works, and then one for remembering who's the president, and then one for loose association. So that way, if the robot is talking about a subject, it can get quickly over to the correct subject that the user is going to change her into having. And we feel like sometimes if we have enough loose associations, that will actually get the structure that the concept net that the user is like working from. So where I was going with that is, I think that we have to question whenever we think an associative structure is in play, if there is any other algorithm to do something similar for us, or if we're just not seeing there's a connection that's intrinsically there, we're not seeing it, and now we're creating associative memory to band-aid the fact that we're not actually looking at the correct graph. So a lot of times association-based learning is more of a repair job, so we don't have to fix the thing that's actually broken. And a lot of times probabilistic reasoning is yet a band-aid to fix a broken, hard logical system that if we would have fixed the broken system first, we might not have needed probabilistic reasoning. I'm not saying there's not a place for it, but I mean, in Logicmoo, we use a ton of probabilistic reasoning to connect these narratives together because there's just so many possibilities. The only way that we can like expand our search tree of possible places to go is stochastic probabilities. But initially, the structures that are there are supposed to, if I did everything right, which I can't and I won't probably, I wouldn't have to use any probability or whatever. Because it's usually, now if we can convert these probability networks into something we can freeze into a decision, because that's actually what we do with them. They end up becoming priority systems. You know, our association systems are, anytime we have a truth value, we have to find one value that's higher than another in those truth values. So we end up really never being the analog stochastic network that we want to believe that we need, because we end up always having to have a total order of search. And so it seems like, so I mean, I feel like as long as we're wary of when we're using probabilistic logic, is it a band-aid for something that's broken or some piece of missing information? Well, if we found a way to get that information or generate that information, I mean, we can use that, the numbers that we're getting. I mean, because these numbers are real and they're important, let's say, because they have functional use. But can we take them and construct the thing that probably created those numbers for us?
Well, this ties in with sort of adaptive history-based inference control. I would say, because I mean I think I have no doubt that the construction of memory episodes, which we all do when we manufacture the memories that we then believe we actually experience.
Oh yeah, that was the most interesting part of what you brought up, is the fact, yeah, we actually manufacture just about every single memory.
And this is largely, it's probabilistic fuzzy abductive inference, right? I mean, it's not, that's a very straightforwardly modelable process, right? Like if you look at, say, eyewitness accounts of crimes or something, I mean, they're manufactured, and they're manufactured usually just filling in the blanks based on prior experience. Like the typical white American will have a false memory that they saw a black guy run and grab someone's wallet, right? I mean, and there's a lot of data on it, and that's pretty straightforwardly modeled by just probabilistic abductive inference, right? So yeah, I can see easily how, I mean, the same sort of filling in the blanks and memory construction that something like a Hopfield network or an asymmetric Hopfield network with strange attractors does through neural activation spreading. I mean, you can do the same thing through abductive, inductive, deductive, probabilistic reasoning working together in a logic network. I think that the Achilles heel of all this is inference control, then, right? Because you're doing inductive, abductive, deductive reasoning on a mix of abstractions and a whole lot of very particular data points, which are things that happened in your life history. And doing sort of adaptive inference control means mining patterns through your inference history regarding like which inferences were useful in which contexts in the past, right? So it's like when I constructed a memory about, you know, someone stealing something or someone rapidly moving an object before, when I constructed a memory like this before, what data did I pull in and what sequence of reasoning steps did I use? And so I think if we're gonna do all this using induction, abduction, deduction, and probabilistic reasoning, still the question of so the question of, do we need a sort of dedicated specialized episodic memory store, comes down to inference control. Then it comes down to like how are we mining patterns in our prior episodic memory narrative related inferences, and how are we storing and retrieving the patterns in our prior episodic and narrative related inferences, so that we're then plucking these, you know, inference control template patterns from our episodic inference control memory, and then using it to guide the probabilistic matching. So then I feel like even if we're going to use probabilistic logic for this, the basic question and problem is still there of whether there's some special episodic memory storage and retrieval mechanism, and to what extent is it like human narrative customized. The problem is still there. It's just kind of lifted to the level of inference histories rather than of concrete episodes.
Yeah, so something Psych did when I used to work on Psych, and we set up this memory of all the inferences it had, and it would like find that this particular query pattern yielded a lot of results back. So if it needed something with a lot of results, it would go for that query. What we found is that there was certain types of ways people would put data into the machine that would make an inference really productive. Like if you had something that just returned a list of integers, man, that's going to go all day, and into infinitum. And so we found that when we tracked our query patterns, that we ended up upvoting sort of the ones that were most productive. And of course that wasn't great. So we started tracking the ones that were good for successful inference at the very end. And there were certain ones that were always participating because the system had to pass through. So no matter what, I was going to say, it ends up being a whack-a-mole on what sort of pattern that was ideal from the history, because for in one sense, if you wanted to make a new deduction, or if you needed it to make a new deduction, then it's always going with what it used to do. It wasn't going to do the new thing, or if a new piece of novel information came in that had no history on. So you almost have to have an episodic system that every time there's success, it sort of says, this is the narrative that created that success. Just that's one approach, is that we start organizing these things into individual things, and then at some point we start merging them together. And before you start merging them together, you figure out your sort of total lattice of scary queries, of queries that are going to. And then once we figured out, well, there's only about 25 different styles of queries that are coming in the system that are awful. Now we just have to have those 25 patterns. And I was going to say, you could call these patterns narratives in a way. But what you asked about episodic memory, I'm so interested in episodic memory because in Logicmoo, I'm using so much of it, and it's all generated on the fly. I try to do as little forward chaining as possible to generate these memories. And if I do have something probabilistic, I try to still return it with the probabilities in there, because I feel like the receiver of the query is going to understand those numbers just as much as the heuristics of how we search over those. So for example, who stole my wallet? And the answer, instead of telling you who, it's some thief. It actually tries to give you the most general answer. And then, well, what was that thief's skin color? And it returns completely average or whatever. It's not, it tries to give non-committal answers in a way to let the consumer place the consumer of the query, the thing that asked the query, to interpret the result, rather than trying to ground the result immediately, because that's real expensive. I don't know if that totally helps, but on the episodic memory, it's you have to, if you pick a normalized form for it, it fits together a lot better. Sometimes normalized form, if it was some sort of a truth value, every truth value can be compared to every other truth value. So we need a lot of specialization if we really want to make use of the truth values, I think, sometimes. And if that answers some of that. Yeah, I feel like I must have missed like a third of your questions, so in there.
Well, there's not even entirely a question as much as a stream of consciousness brain dump on these large and confusing topics. I don't know. Alexey, I don't know if you have any related comments on episodic memory, which you've thought about a bit also, but it is a big and messy topic.
Well, yeah, we had some discussion on episodic memory for OpenCog in general and the virtual assistants in particular, but I'd like to highlight another possible aspect of this discussion, is that it's not only about episodic memory, as far as I understood, not only about the past, but also about the future. And what I saw in these examples with virtual worlds and spiders is the necessity to have a world model kind of. So I'm not sure if there are some connections to Solomonov induction or something like that, but the first question which popped up in my mind when I was listening to the talk is how basically to represent our knowledge about the world, how to model this. Should we use logic and backward chaining, or should we combine it with probabilistic modeling, like probabilistic programming, and so on? So I wonder if you see some connections to this questions, or are they absolutely irrelevant? What do you think?
No, I think they're relevant. We have to actually decide sometimes what is going to be probabilistic, and because some things are going to be until we can like make them more solid, to sort of like, you know, when you're just trying to when you have a large search space, you can't do it unless you have some sort of a, it's hard unless there's some sort of a search order that you're going to use, a heuristic to get through. And so the best probability is the amount of experience versus, you know, I've seen this 20 cases and 50% of the time it was this way. And that's different than seeing it 10 cases or one case and it was always this way. We always have to, that's always an important factor, probabilities are. But that is, it may or may not be called probabilistic logic when we're doing it, you know. We may not turn everything into a probabilistic.
Well, it may be not too important if it's probabilistic or not in my question, but you have these images with spiders and the imaginary and real webs. So I wonder how they can imagine these webs. So are there some built-in skills, or how you can represent the capability to imagine this particular webs? So this goes somewhat outside logic. I mean, of course, we can do everything with logic due Carey-Horvath's correspondence, but I don't expect you to use Prolog to model these webs. So I wonder where your agents know how to imagine the world.
Yeah. I mean, it feels a little bit pretentious to call it imagination, you know, or like even sometimes call learning. It's just sort of like, no, that's not human imagination. That's not real imagination. But in a way, the reason it's worthwhile to call imagination is because it's mapping the world state into a particular data object, and then mapping a narrative state into another data object. And these two data objects were not actually ideal for narrative. So there's a little bit of data loss, like purposeful data loss. And then by the time they become into the same sort of structural system, they can be compared under that system. So, for example, if you're comparing a web that's attached to a tree trunk to a web that's attached to a door frame, the analogy between the door and the tree trunk might be a little bit obvious there because we have a web attached to it. The process that attaches that web might actually take several steps in the narrative, and what it ends up doing is comparing the result of the narrative more than the narrative itself. So it's encoding these two different things into the same thing, and then it can make those comparisons. And what usually the problem with making analogy is that, well, there's a couple problems. One is that we could be completely associative, or we can go without any structure at all and end up trying to have an analogy system that way, or we can have too much structure and miss the analogy. And so logically, what I'm looking for is that I can't get the structure out of the world, but I can put structure into the world. I can't guess what the world is doing as easily as I can actually make the world do something. So these analog comparisons are actually based on two systems trying to create the same thing with a little bit of data loss. And so without any sort of stochastic comparison, it ends up making a comparison that looks stochastic from the outside. So we're looking at it and saying, how the heck did it connect the tree trunk and the door frame as places to build the spider web? Well, it's because the spider web was actually mentally built onto there, and it failed to build onto the cloud. It failed to build onto the person walking by. And so that's how we end up making the analogy, is by finding where does it fit at all. Oh, okay, we have some fitting here. And then we don't have to do any fitting in the real world because it just fits. It happened. But we still try to emulate that real world by trying to generate the event calculus that would have produced a similar virtual world. So it's kind of like, instead of trying to see the data, you're trying to re-replicate the data. So it's a little bit like generative vision. If it generates a duck and it's looking at a duck, hopefully those two ducks will be similar. But it's only trying to generate, so the difference is between that example of generative, is it's actually trying to generate a duck over here and then generate a duck in a really contrived manner over here. And since it's using the same database to generate both ducks, they end up it becomes really easy to compare them. So it's definitely abduction. And abduction, which is where you're trying to replicate the process that you just saw. So we're trying to replicate the thing we just saw in two modes. One is completely panned and the other is completely a poor rendering, and then we find that connection. So imagination is when we imagine something. If you imagine the ocean and I imagine the ocean, we probably have a very different level of detail between our imaginings. And so in Logicmoo, I leverage that, take advantage of that, is it doesn't have to imagine very hard. It just has to imagine enough that it believes it imagined. We don't have to believe it, but it has to at least follow the rules in which, if it had imagination, that would create within the system. I don't know. I hope that answers some of it. So the thing that's goofy about Logicmoo, when I describe it, it sounds really terrible, but the system is based on finding the best way to lie to itself in almost every situation. So the analogy is not similarity between two things. It's a similarity between the fact that it thought something, lied to itself and thought something was something, and it got away with it. If it could get away with it, then the analogy is made.
Well, okay, but the core question here is generalization, I guess. So it's definitely a good direction to compare things, not on the level how they appear, but on the level of the hidden variables, hidden structure, which allows you to generate these things on different levels of details. But the question is how this generalization is done and how general it is. So what regularities you can extract.
Yeah.
Okay.
Which comes back to inference control to me, because I feel like doing probabilistic reasoning and pattern mining with the right outcome bias and so forth, I feel like we fundamentally know how to abstract those generalizations from historical data if a system has the episodic experience. But again, the control of inference and pattern mining to be reasonably scalable and practical to do. Again, we don't have a magic trick for that. We have the concept of history guided adaptive inference control, which again becomes a turtles all the way down thing, where doing the inference to guide your inference control also becomes intractable. And what could intervene to make it more tractable? I mean, it's either some customized representation with associated special matching algorithms for episodes, or some customized representation with special matching algorithms for inference histories about episodes, or maybe it's both, and they're linked together, right? And that, I mean, I played with this very crudely in the 90s using asymmetric Hopfield networks, which are like attractor neural networks, which can store sequences of things, right? And then you can sort of prompt them with pieces of the sequence, and it will fill in the rest of the sequence. Like it will do memory construction, basically. And with in OpenCog, theoretically, one could do that with ECAN, which is basically like a Hopfield network with slightly different math, although we never got that far with the ECAN experimentation. So what one possibility is to use this sort of attentional dynamics and attractor formation and nonlinear dynamics to do the pattern completion involved in episodic memory retrieval. Now, direction we've never gone in so far is like train an asymmetric Hopfield network on temporal sequences, which are sequences of inference steps, right? So you're trying to like get the attractor network. So you know this early part of an inference, a later part of an inference, maybe a middle part of an inference. You clamp part of the attractor neural network with that. Then you have it self-organize and fill in guesses regarding what the other parts of the inference chain should look like, right? So I mean, you could use this sort of attractor neural net type memory to guide the retrieval of appropriate inference chains to try for doing the constructive memory, the construction involved in episodic memory, right? And that's so there's certainly interesting directions to try. And so then from a philosophical standpoint, the question is like, do we have good enough reason to believe the inductive biases implicit in what an asymmetric Hopfield net or ECAN net is doing when it fills in the blanks? Like, do we have reason to believe the inductive biases implicit in this sort of attractor neural net match the inductive biases we want for episodic memories, right? And then in the human brain, of course, what's happening is presumably the attractor neural nets in cortex are dealing with this. They're linked into limbic system and basal ganglia and other parts of the brain, so that while the memory attractor is forming through this sort of self-organization and convergence to an attractor, there's linkages going back and forth to emotion and goal-oriented parts of the brain, which is then nudging the attractor formation, right? So I mean that's which is something that conceptually one could build into an OpenCog or Logicmoo type system, right? But that's like you need real-time feedback to emotion and goal systems, which is guiding the sort of convergence to the memory or memory-related inference attractor.
Well, one thing with a system is I want to see, like what we just described here, is if we were to put the sub-vocalization loop and get that involved into that network, to where there's always this other guiding principle that it has to account for, and that is the thing in which it's generating subvocally, let's say. So it always has to narrate what it's up to. I mean, the question is, because there's a lot of problems that only get solved when we add that component.
Interesting. Some people do that, right? Like my daughter, my older daughter, who's 24, she thinks in words. She even thinks in printed words. Like she sees like a ticker tape of printed words floating by while she's thinking. Whereas to me, the idea of subvocaling like a verbal narrative of what I'm doing is like pretty creepy and insane. Like at least on the conscious level, words don't play that big a role in stuff I'm doing. Like for me, verbal communication is a separate process that I feel like I'm invoking when I need to do it. But it's not part of my episodic memory or planning or thinking process. Words seem like a big cultural mess I'd rather avoid whenever possible, right?
Even if it's not words,
that is a cognitive style that some highly intelligent people have, and I could see plus and minus to it, right? Because then you might get an AGI whose thinking is overly tied to perversities of human language that way, right?
Certain thoughts it can't have because it has the time to language and didn't have the language for it. Yeah, there's certain limitations sometimes. I think if we look at sometimes nonverbal, like the way vision works, is the eyes are not speaking words, but maybe it converts to words. I mean, by the time it gets to our brain, our eyes they're already processed something that we can understand.
Well, they clearly don't convert to words, because
Mhm.
people who, like wild children who never learn language and never learn words, can still see, and so can a dog, right? So I think, but there's a,
I'm saying there's a language component somewhere in the eyes. There's a protocol between us and our eyes that at least allow these things to convey complete thoughts.
well, I mean, the us is itself a sort of emergent attractor that involves input from vision and from language and a bunch of other things, and is integrating them somehow, right? And yeah, the extent to which vision and language are mapping into some common abstract relationship where the interaction is enacted versus there's sort of lower level coupling and cross biasing between vision and language. I guess both are true in the human brain and mind, right? And exactly what role the convergence of different modes into a common semantic representation versus feedback between the different modes at all the levels of recognition and creation that they're doing. I mean, exactly what roles all these play, I guess we don't know in the human brain, and we also don't need to do it exactly the same way.
We can do what's convenient. Yeah, what works. And even whatever thinking that we're doing, it's usually very structured, at least, even if it's without language. I just bring that up that
is it? I don't know. My thinking is often not very structured. I mean, maybe your thinking is very structured.
Well, actually, if you have a thought that wasn't your thought that suddenly came into your head, you would go, "That's not my idea."
That happens to me all the time. It should be honest. So if I were medieval, I would call it divine inspiration. Instead, I just sort of think my unconscious is doing some parallel processing and spinning it into my deliberative working memory, right?
Yeah. Well, it definitely, you could say that's not my thought. Like you have a notion of a vetting process. Was that me or was that something else? That you can recognize and make a decision on already. I mean, just the fact that you can say it wasn't yours.
This sort of thinking is interesting because I think different people have different model of how their own thinking is working, and we can then drive our AI designs based on our own models of how our own thinking works. And fundamentally, none of us really knows how our own thinking works on an unconscious level. Like I usually feel like I don't exist. Like there is no central I doing things. There's just like clusters of activity that are happening, and then now and then some model of I needs to surface to carry out some social or cultural function. But then how much of a model of I exists in my unconscious brain? Like I don't know, right?
It's quite possible that your unconscious brain has its own consciousness, that you it isn't in control of your body, but it has its own thoughts that are separate from you.
I would say. I mean, I think my finger has its own consciousness, which is a little distinct from the consciousness of my brain. And if you cut your finger, the finger hurts. But if you get in the right state of mind, your brain doesn't have to register the pain that the finger is suffering, right? So the consciousness is its own big topic that which has many aspects. I unfortunately have to go do some childcare related stuff now, but I've transferred the ownership of the call to Matt Ikle, who can keep it going or transfer it to someone else. But these are deep, fascinating, important topics. I think we should actually continue this discussion in a follow-up AGI discussion session, because we certainly haven't gotten to the bottom of it. But,
yeah, definitely. I look forward to that. Oh, thank you. Yeah, thank you. Oh, Ben left. Yeah. So
I guess he transferred to me. So
cool.
I was following Ben's latest discussions, because as I was listening throughout your conversation, I kept going from that perspective that he was just talking about, in terms of the fact that we all know or try to understand to the best of our conscious abilities how we process information. And that kind of goes to a point that at the latest AGI conference that I tried to make, which is one of the things that I think we need to kind of be aware of as we move forward is taking as many diverse perspectives as possible into account. Again, he was talking about one person processing everything using words, while another person can think through visualizations more easily. I'm trying to tie this into the idea of the proto-narratives as well, and I'm not sure what my thoughts are. I'm just kind of
on the way. There's a lot of cognitive models that are based on dual coding. For example, we're going to connect pictures to words, so where the pictures fail us, the words will connect for us, and vice versa. And usually, when we combine two modalities of thought, we have the ability to interleave between them where it's convenient to be able to make a connection. And when and so in Logicmoo with the proto-narrative system, it's sort of trying to do, it converts everything out of, like, say, sight into speech.
Mhm.
It's not a complete reuse of dual coding, because it's definitely not, but it's trying to find this modality that neither one fits into to also add connections with. I bring that up because almost every cognitive system is finding two forms of something that are just not quite right together anyway, or that have this impedance mismatch, and then usually putting an association between the two, hoping that will sort of solve the mismatch. And there's nothing wrong with that. And Logicmoo is just doing the same thing as everyone else in that case. It's trying to, instead of tying speech to vision, it's tying speech to this event calculus and vision to this event calculus. And then, so what do you think of that, or A's opinion on that?
No, I mean, I see that. I'm processing, but and to a certain extent that brings yet in a sense a combined modality into it. Yeah, I have to think about that.
Kind of where the point is coming from is, if I'm more of an auditory thinker, and so I said, okay, I'm going to have to convert my vision data into some form that the audio data can work. The word data, the logogens can sort of have influence over the Imogen version of thinking, and at least get them into some space. But exactly where I was going to go with that is that, yeah, I think someone else would have gone with a completely visual system, perhaps, and make it go the other way. And I do think that by taking the harder of the two paths, so a lot of times we think vision processing is easy, or hard, and word processing is easy. So if we have a system that's strong with vision processing, we're going to have the best of both worlds somehow. And that is probably the case. Like when Roger Schenck made his conceptual dependency parser, it always related, no matter what got said, into these role frames that fit like this version of almost like visuospatial memory. So as long as the words made sense visual spatially, then that's what got parsed. And
yeah, I keep going back to how that perhaps ties into, you talk about the a consciousness versus
a query engine, maybe.
Right. So I'm biased from my training. I think a lot mathematically, and I sometimes try to analyze how I process ideas from that perspective. And this goes to the probabilistic aspects as well, which is, and I think Ben was talking about this as well, which goes to essentially your history. And somehow I follow whatever my intuition says, but that intuition is founded upon experience. and I'm probably going into a whole different realm of thinking here, the separate one that we talked about earlier, but and it seems to me that that intuition is, in a sense, whether it's, I think what Alexey was talking about, probability per se, it does certainly guide the direction that I will take. Not sure if what I'm saying all
No,
makes sense.
yeah, it definitely makes a lot of sense. It's, yeah, that, I mean, if you could, so one thing is if you actually, when you remember a situation, you actually decided that you're going to remember it based on a particular thing. Like you go to a particular restaurant and you decided that the reason that it was going to have a better than another time was going to be something based on like the flavor, how good the food was, or if the food was cold this time, or how long that you had to wait for service. That's going to, you pick out at least something, and then you can start doing the mathematical of, you know, what's the chances of this restaurant being good on a Tuesday. And if you're doing that, you did pick out some elements first, but my point was going to be is that you might actually ask yourself the question every time you go, so that way you can update your statistic.
Right.
Yeah, but what if you never asked yourself that question? I don't know if the statistic would be there at all. And that's where I say what consciousness is that something decided picked out that statistic and had to ask, because if you never ask yourself, it's not going to update it. It's not going to update your impression or knowledge of that restaurant on a Tuesday. You know,
So if you've never gone to the restaurant in the first place, you have no statistic, but you still have some reasoning that leads you to try that new place.
Yeah, it's got to be outside of whatever that statistic was going to be that gets you there now. It's this thing that says, oh, we're going to stop doing statistics for a moment, and we're going to do this other thing. Makes that inference choice.
And so the question is, upon what is that initial choice based?
Yeah. It seems like that choice is going to be some kind of rule of thumb. And that rule of thumb is something that you can tell yourself, and you could write it down on a piece of paper, maybe you couldn't, but it's something that you could either not know or know. So I guess what I'm trying to say is it means that it's part of something that you have that is outside of that is actually enumerable in
So how do
that's
we
only
decide?
to your consciousness, not to some sort of sensory apparatus.
Okay.
It's part of what you imagine. I feel like there has to be this imagination process that you willfully do in order to tease out how you feel about this place you've never been to. You know.
And so where does that arise from?
Yeah, I think it's pretty. I mean, okay, in Logicmoo, I'll tell you what I believe is that we have these about 150 so themed stories that we apply to every situation, and it ends up sometimes just using poetic reasoning. So if we were complete blank slates, I mean, there's definitely a lot of stuff inside us.
Right.
That, yeah, and the amount that's there, I think, is a lot larger than we would assume, and I think it already has those decisions made for us. You know.
So from a biological basis.
Yeah. The amount of stuff that could be there, you just look at a beaver and all the details it has to do to get a dam built, and no one's ever taught it. That's crazy if that much information is going to fit on a beaver's DNA. Something's got to fit onto ours too, you know, that's that contrived.
So tying that back, so that's the idea of the proto-narrative.
Yeah.
And then how do you come up with a base set of proto-narratives for an AGI?
Yeah, I mean, that's supposed to be the hardest question, and I think it's hard. You know, it definitely is. But we can sit here and I can sit there and actually add more. I may never get the right ones, but I feel like I certainly can put more in. You know, so I don't have to pick the right ones at the start. I just have to eventually get all the right ones in there.
And I guess this is something that's always kind of intrigued me, and maybe I don't know if this actually plays into it at all, but I'm fascinated by the brain's unconscious processing. And kind of going back to the dreams at the very beginning, I Dream in Prologue, the shirt. If I'm like really into some hard problem that I'm trying to solve, I find that one of the best things to help with that, and I'm stuck especially, is to step away from the problem, do something completely different, go to sleep. And I just remember this from my undergrad days, waking up at 2 a.m. with a fully formed answer, writing it down, because if I don't, I'll forget it. And going back to sleep, and it was completely correct in the morning. And just how that relaxation fits into that unconscious processing that I was not aware of happening. I may have been thinking through some things at various points, but I mean, I didn't guide it.
Yeah. Have you ever read Gazzaniga? I don't know.
It does not sound familiar. How's that spelled?
Gazzaniga. Oh, here's one of his books. Gazzaniga.
Okay. I think I've heard of it.
Well, he's always talking about how, well, what he did in the 60s is people with the left and the right hemisphere separated, he did a series of experiments where he would show them a picture of something like through the left eye, and then ask them what they just saw, and they couldn't tell you, but they could draw you what they just saw because of the way the brain was connected. Right. It had no idea. And then he would ask the person by isolating the two ears to do something. They would do it, and then you would ask them, why did you just do it? And they would they confabulate a story based on something that side of the brain thought was logical, because that side of the brain thought it did it. Both sides were trying to own those actions. And so one side had made up a story of why it did these actions. And what it was about was that there could be definitely more than one consciousness in the single brain that think they're part of the same body. So our subconscious mind, we might think it's like flighty and illogical, and it just is the trash heap for all of our experiences we didn't want to think about. But it could actually really be as logical as we are, maybe even more logical and smarter than we are. And it's just it's filling in all sorts of capabilities. That it's giving us almost all the capabilities that we have. And most of the time, we're just taking credit for the things in which it thought up, because we think its thoughts were our own thoughts, and so the idea is, go on.
Yes, yeah. I wanted to ask you: do you think that it is separated from the start by design, or say when we are babies, it's unified, but over time, different parts are just turning into independent modules just purely for efficiency reasons, but at the beginning we just yeah,
that's a really good question. Like, it reminds me of this thing where I learned to wash my hands at some point, and it took out all my conscious effort to do that. But then now my hands wash themselves for me in the sink, and I get to think about other things. And maybe at some point in my life, I was really connected to it, and I couldn't do all the little motions unless I had total conscious thought put into it. But now, I don't know if my hands do it, but what I'm saying is I wonder, like, if whatever part of that is now separated from my consciousness.
Interesting.
When we talk about things being separated. So how many parts of our younger selves are actually not even connected, that they're no longer part of our consciousness? I feel like our goal in life is just to get everything that takes mental effort farmed out to some part of our brain that we don't know about, or we don't have to think anymore about it.
So here's a question spurred by Nils' line here. I'm wondering how all of that, right? We develop these things that now are unconscious. Tying a shoelace, you can do that without even really concentrating on it, or like you said, washing your hands. And I'm wondering if how that fits into the prior discussion of kind of the nature versus nurture pre-built pieces.
Yeah.
I'm wondering if there is a tie-in. I don't have an answer. I'm just kind of like,
well, everything that we are born already knowing how to do that take no thought, those are definitely nature. But what about these things that that we don't ever know that we know? Things that could be innate within us that we just never in our life get even bothered to do. There's got to be some of those things.
Right. I mean, what innate things? So you're saying what innate things are we not even aware of and never become aware of throughout an entire lifetime?
Yeah, and what if the subconscious is filled with some of those? And I wasn't trying to change the question. It's still the same question: is this type of whatever reasoning that you weren't able to do while you were awake, your subconscious mind was able to do for you? That's. I'm not going to say that that's innate. It probably had to learn the problem at the same time you learned the problem, but we don't actually know for sure that it was innate.
I mean, if I'm not in the problem, then nothing comes out, right?
Mm-hmm.
If my conscious mind didn't set up the difficult problem for me to try to solve in the first place, then nothing happens in the unconscious. So I rarely wake up and saying, "Hey, I've got this brilliant new solution to this problem I've never even thought about."
Mm-hmm.
But it really takes a lot of hard effort digging in and hitting these dead ends for that unconscious, the example I was giving earlier, to come to fruition.
Mm-hmm.
So it seems like there's definitely this connection that. Pardon? No?
Go on, Matt, because I think I interrupted you.
Yeah, I was kind of, again, I'm just raising questions more than trying. And maybe that's just my experience. Maybe some people can have that without being into some hard conscious problem. And I've never experienced that. But that would be something to think about. And that's where this imagination, where does Van Gogh's wild worlds originally come from?
Yes, something that a question that is kind of related to that I've had for a while is how can nature formulate knowledge if it doesn't have if it hasn't learned the vocabulary that nurture would provide? So for instance, so we have instincts. Okay, we have to eat, we have to reproduce. Okay, but in order to say, okay, we are attracted to certain shapes for the purpose of reproduction, but how are we going to recognize these shapes if we don't know how to see? If we haven't learned how to see, and how is the nature knowledge, process knowledge, is going to formulate that in someone that doesn't know how to see? Well, we know that blind people can enjoy the shape with the touch. So it has more to do with shaping the 3D world that we reconstruct. But even these shapes in the more abstract 3D world, okay, so the DNA encodes that and hopes that we're going to learn how to properly reconstruct this 3D world. It's kind of a mystery to me.
It's really, it is a mystery, and it's interesting how inexpensive it must be. At least because we're all born with that costing us kind of nothing. At least consciously, it doesn't. Our ability to know and see shapes doesn't require a lot of thought. It's almost like it's handed to us for free. Like even our ability to imagine isn't some like difficult emerged skill that we get. We're born with these certain skills that you would think would be computationally hard. I guess like what I'm saying is, so a blind person who feels this pop bottle knows the shape of it now, in just the same way a sighted person would know the shape of it, and it costs them probably equal amounts of thought, which was barely anything, because somehow they were born being able to already do 3D mapping. Oh, if they are born already to do 3D mapping, then they already have 90% of the wiring to be able to be born with a memory of a 3D shape as well.
Mhm.
Yeah, that makes sense.
So there's the nature, it's the kind of the more abstracted idea of 3D mapping.
Yeah, I mean, if we are born with the ability to 3D map, how many extra bits of DNA is going to take to actually give us a few to be born with a few already with maps that exist, like the shapes that we like in 3D? They could be there.
Which that whole 3D mapping, of course, there's an argument, what dimensional space do we actually live in, but from a physics level. But it brings me back to kind of the idea of, this is maybe an off the wall thought, but I was just having a discussion just recently about the idea that in the Renaissance, there was a rediscovery of linear perspective, the vanishing point for painting. And obviously, at that time, people were navigating in a real world, but they couldn't figure out how to put that onto canvas.
Right, like all the art at the time was this one kind of way, and it took like something to suddenly flip something on where everyone could do this thing slightly more complex and interesting. So what is that what kind of happened, if my memory serves?
Yeah, that's the question, and what changed there, right? I mean, because you're getting this, we're navigating with a 3D map through the world, but then the impression was always painted very, up until that point, in a very two-dimensional manner.
Weird.
Until the idea of science basically kind of coming in with the rays and the vanishing point from different perspectives.
Weird.
Literally changing how art was painted.
Oh yeah, so I mean that really is weird, because that makes an argument that that actually whatever inference you were drawing from looking at 3D art now or 2D art then was probably inaccurate, because we don't know, because it maybe not that we have 1D art, but maybe 1D art could have been a modality at some point in our history. I don't mean evolutionary, so I just mean history of man. So I mean, we don't know if 2D was ever, that 2D perspective was actually what the brain was doing, and then people just got more fancy, or if 3D is what the brain was doing in those whole time. And yeah.
And so, maybe we are actually successfully navigating in, I don't know what the latest
0D world
physics dimension is. I've heard 11 dimensions or 26 dimensions. We're just still thinking we live in 3D, but we at some point maybe we will understand and perceive higher dimensions.
Yeah.
Just like, that painting was a two-dimensional, and for a long time, the two-dimensional representation, very flat. And it took that breakthrough to kind of understand the vanishing point to kind of begin painting in 3 dimensions and understanding things. Maybe that I'm just trying to extrapolate to, well, maybe our perception is just this 3-dimensional flat representation that eventually maybe we'll be able to see things in these full 26 dimensions if we just get it right.
And when we see in 26 dimensions, we realize that it wakes up an instinct that was always in us, but we never experienced.
Yeah.
I was kind of joking, but
I mean, this goes way into speculation.
Whatever dimension we think it is innate. We are born, if we're in 26 dimensions or 11, whatever we have, we are born probably with that. I guess someone could disagree with that. I'm saying that we definitely would have some innate number of dimensions, or 0. And some people think it's 0. I mean, the whole idea of the that we are complete putty coming in here, and in our dimensionality is something that we learned. And it's not,
You
you
mean from
can't do that wrong.
You mean from the Big Bang, what happened, some kind of a singularity which has 0 dimensions in its nature? Maybe that's something that can be an analogous explanation in regards to 0 dimension of existence.
Yeah, well, I was considering like one-dimensional is something that we really are just stimulus response that's completely unformed, and then certain things happen to us at some point that bring us into whatever we see, that gives us the ability to see in 3 dimensions, you know, that we're emulating it somehow. I mean, we're even emulating 2.
Maybe it's just the illusion, so that the things are happening and we are actually not conscious. We don't have free will. We just have illusion of free will and consciousness. Maybe.
Oh yeah. Yeah, I do think that whatever I am as far as consciousness goes, like the thing that I call me, might only be a feeling that accompanies this other process, and then the other process is actually the conscious piece, and I'm just attributing that feeling that it's being produced, and I'm giving it a name called consciousness. That's
I see what you mean, and in a way, that's why the Logicmoo and your project is interesting, because you are coming from definitely different direction, not from the bottom up. It's more from a very interesting standpoint, and then trying to somehow induce this all these concepts that are being discussed, especially for the artificial general intelligence work. Yeah, that's interesting, and also you are using very interesting technology in form of Prolog. And I liked when you said that it's not a good language for AI, but it's a good programming language for a lot of things that other programming languages are not good at. That's interesting.
Yeah. It's kind of difficult or almost dangerous to be using Prolog, because people think, oh, you're using Prolog for AI, and it's like, no. Prolog is merely a language that produces no side effects in certain situations, and so forth. It's more of just a specialized language than anything that I could ever derive inference from, or that the AI would get inference from. And a lot of AI is about trying to solve a problem, solve a query. And like when we were looking at the AI state-of-the-art leaderboards, we're seeing how well they solve a question, and not how they're actually, not if they're trying to implement something that doesn't even resolve a question. I mean, so if that was what the leaderboard was about, you're trying to the creators of the solutions would be trying to create things, put things in it that would only solve queries. They're not trying to add anything else. I mean, it all has to go towards that one end goal. And if there are pieces and aspects of being human that are not be able to be pushed into that modality, then they would be screwed, you know. If we have some aspect of us that wouldn't be solved using a query mechanism, then that would need to be, energy would need to be put into that somewhere.
Yeah, they're looking at things. They're looking at things as if minds are not stateful, but minds are pretty much very stateful. There is a whole history of events, experiences, events that influenced the current state, and of course future evolution of this state of mind. And yeah, a lot of these hyped AI technologies of the day are just looking at very, very constrained and very limited types of, that's why they call them narrow AI, because they're very narrow. And if you really want to get to the general intelligence, or at least something that is general than these narrow AI approaches, then there is a lot of things that are much more, we need to take into account the evolution of the identity, how the identity of the system is evolving, and how can we somehow channel in a proper way, or at least bootstrap it and give it enough flexibility to grow on itself. So I completely agree with the leaderboards and query-based performance metrics of that kind.
Yeah.
I have one more question, if you have time. You mentioned the client quality of your system. Can you expand on that that topic, if I understood that in the first place?
Yeah. So when you look at a number like 1, if you evaluate 1, it comes out as the number 1. Or take any number, and it's kind of like a self-evaluating object in the programming language Lisp. We have a class of things like a string. If you evaluate the string comes out that you just evaluated. So that's kind of what I mean by a client, is that that whatever data term that you see might actually be considered, if you can frame your system in such a way that the answer to a particular term is the term itself. So like the mother of, so for one of the terms in it is like the mother of an organism, or mother of X. Her name might be Julie, but within the system, she's the mother of someone, mother of X, and the system keeps terms on that level, because any sort of a evaluation that actually changes the structure of them would change their meaning. So the meaning status is the mother of X, and so it's real. In order to preserve and have like control of the amount of data loss the system's going to have, that's why things are quantities, even things that regular Prolog programmers might not call that in the system. Since we're in charge of what the interpreter does, we can make it do whatever we want. And if we say that mother of X is a quine, then it is. So it's very easy to implement in that way, to say that nothing can be evaluated like a function. Because every function is, the result of every function is itself. Yeah.
Interesting take. Yeah, I know that Prolog has a lot of capabilities for implementing meta interpreters. It's very flexible in that regard, from what I saw. And if I understand what you are describing, that means that you can obviously decide how things are represented and processed in very flexible ways. And if something or term is useful to stay in that form without any additional interpretation, then just keep it in that form. Is that right? Or
yeah, that's right. And it costs nothing. I mean, that's a cheap operation. All you do is you just pass the term structure around. Yeah, it's kind of why. I mean, if Lisp would let me do that, like if Lisp would let every function actually be implemented as a macro, that would be the same. That would be an analogous programming language, and it would be the same. That's what I'm using.
I see. Yeah, yes, excellent.
Yeah, and you know, so ideally, whenever I have a variable within a structure, and then that variable is bound, this is the beauty of Prolog, is you now have a new structure everywhere in the program. So so it costs very little. Lisp used to call these locatives. So you would say like A is equal to B, well, in Prolog. Anytime you have this big graph and you just update one variable, you don't have to update it throughout the graph. It's updated everywhere instantaneously.
Excellent.
And that's, yeah.
I see a lot of efficiency there, but there could be one problem. If, for example, I know that most Prolog systems of this day, at least ones that are used a lot, are not parallel. But I know that few also support multi-thread processing, multi-processing. I don't know how this would what kind of meaning, or will this kind of variable sharing present some kind of issues there? For example, if you want to probabilistically explore several potential branches of future, and then you do some kind of variable binding for some of the terms, or within some of the terms. I don't know if you share the same term with other threads of potential future evaluation or sampling. If you want to, for example, to estimate certain probabilities, then maybe this can also be helpful and create a more efficient system. But maybe sometimes, if you, for example, need to rebind in some of the threads of future exploration, the same variable, I don't know if that could pose a problem.
It kind of is. I mean, the multi-threading between. So first thing we're talking about is the multi-threading, if two threads need to have if one thread needs to bind a variable, will the other thread get the binding? It has to go through kind of a copy process or a term exchange process through some kind of a mutex. But secretly, that's actually going on with every programming language. They just have lots of constructs to make that not very painful between like threads sharing data. And so, and kind of recently, people started adding these heap structures where in Prolog, where if you have a hash map and you update it in one thread, it's updated in all threads. But the way those work is they secretly make a thread just for the hash map, and everybody just goes through a special API to get to that, you know, threads data, and it's still copied in and out. But yeah, secretly every language will have that one problem. It's just as long as you create constructs that make that not feel like a problem to you as a programmer, you're kind of okay with it, you know.
Right. You need to take that into account, but it's good because, as you said, there are means to control that to your advantage. Or yeah.
Mm-hmm. One thing that I thought I heard you say, but I didn't. I was kind of guessing is if you were trying to update, like say a numerical value, let's say it needed to be multiplied, like you change this one numerical value and it has to be changed with say x is equal to y plus 1, and now we're going to bind y to some value. We want x to be updated automatically, like something. But probably what I was thinking you were saying is like a floating point number, or like say a statistical number, or maybe I just made that up. There is some ways of doing that by representing real numbers as as integer components, and then you never evaluate it until the very last minute. So you can keep the equation in its authorial form, and then when you update it, it would update everywhere. And then the only time that we actually care about the computed value is when something actually cares about that value, you know, needs it computed at that moment.
Like a lazy language, a lazy type of expression evaluation or equation evaluation.
Yeah. And they didn't put laziness. I mean, there is some lazy functions in Prolog, more so now than there was like even 10 years ago. And if you do it right, the whole language can be lazy. And a lot of the work of Logicmoo has been, how do I get this language to do these things that not even Prolog does, you know? But it is a lot easier in Prolog than C to do that sort of crazy.
I mean, for example, you can store or bind in certain variable. The term can represent the whole program, so it's very flexible. From what I saw, it's I mean, the list also has this capability where you can, the list is the code, but in Prolog there is in some ways one more step further. That's how it feels. But also what I was thinking recently is, since the original idea behind decorative programming is to explain or describe what you actually want to exist, and in context of artificial general intelligence system, we can talk about some theoretical properties that these artificial minds need to maintain. And it will be really nice if we find a language or existing standardized language, or at least something which is capable to efficiently describe these relationships, which needs to be maintained throughout the history of these artificially constructed minds. And one of those will obviously be the next version of the language that OpenCog Hyperon will use the method from what I was able to see. So that there is, it's not just one. Obviously, there will be multiple of those languages. But in the context of Prolog, I was looking at the, for example, writing the pure Prolog. They say this is a subset of Prolog, so it's a pure subset where you are not using those meta logic predicates like cuts or similar, but you are just sticking with the logic part. But then I was thinking, okay, maybe if I stick with those things, maybe it will be easier to integrate with existing narrow-based AI technologies like the neural net or deep learning neural nets, because some of the models, as we said, they are really limited, and they are truly capable of encapsulating certain relationships, even if we are talking about, for example, simple classification from the image to some kind of a label, and in the other way. And then I really can see a potential where you can use a prolog as interface to this some sort of neurosymbolic system where some of the predicates are actually neural nets, which where, for example, a variable for the predicate, the argument for the predicate, first argument is, let's say, some term which represents the image, and the second argument is some label, and you can use it in multiple ways. You can say, okay, this is the image. What would be the class of can you classify? But you can go in the other way so you can generate some plausible images for some of the classes that are represented by this relational neural network model, and all these things within the scope or under the umbrella of declarative logic programming, where you can have like many of other forms that you yourself implemented from what I was able to see in the Logicmoo. You have forward chaining. We don't have that. I mean, it's not built into the standard prolog. That can be as an extension. So that's why in the last 6 months, the prolog was really started to have some very useful properties for this kind of experiments. But again, this is just one language which will probably be one of multiple who will be able to do this kind of integrative approaches to general intelligence and the experiments. You're just doing experiments at this point.
Yeah, it's very difficult. There's not a lot of people that just that can program in just sort of any language. But what's interesting is OpenCog group dealing with atom space so much. It's similar enough that the OpenCog people's brains already kind of can do that sort of relational programming, I'm assuming, which is kind of unique. But what you said about using predicates where the arguments can be input outputs as you wish, and it becomes a really good, beautiful language for representing your process. So, one predicate could be an entire neural net if you wanted it to be. I mean, it could be used that way, and that's a very perceptive that you're able to pick up on that, and I actually had not thought about incorporating or encompassing, those certain types of procedures as input-output arguments for some of the prolog predicates. I mean, I did some cool stuff, but that's a really great idea. So in other words, if you have a net, so if you have a net that not compares two values, but completes two values, depending on how you bind those arguments, or if you have 10 values that somehow interrelate, you create a predicate, and that predicate could feed towards inward and outward both ways on a neural network. And as programmers, if you work with neural networks, sometimes I do, they're kind of a mess, not a mess. They're hard. You have to write like idiomatic, I'm going to evaluate this, and now I'm going to go back to my programming language. And then I'm going to step out of my programming language, do this thing, and then come back. And there's this impedance that's there. Like, it's like you're suddenly like a GUI programmer has to talk to a backend database.
They are not integrated in natural way. They need to switch even the conceptual approach to using other types of technologies instead of having the integrated system. Like what is the original idea behind the OpenCog? Make it integrated, make it naturally combined and compositional.
Mm-hmm. Yeah. Well, there's got to be whatever. Trying to do something as difficult as create AGI, you don't need obstacles in your way.
Right. Yeah.
Yeah. It would be like for a while people are using this language in C#. It was how they connect to SQL and C# to sort of make them work together, and trying to make that more natural and so forth. And I feel like somewhat OpenCog has done that with the connection with Scheme. Because Scheme and atom space, it just works together so beautifully, and I think even Prolog and atom space will work together beautifully if that. I see it's going to be really nice if Ben decides to say, yeah, we're going to mix even more parts into OpenCog like that. And I guess I saw that they were making atom space for Python. Maybe Neil's friend that Neil was working with someone who had these great Python notebooks that are working with atom space.
Yeah, I mean, there's been Python bindings for a while now. Actually, yesterday Linus added OCaml bindings.
Oh well,
Yeah. Oh, well, that's
yeah. So
yeah, works with Python, works with notebooks, Jupyter
Mhm.
notebooks, as you said. Yeah, kind of flawlessly. Yeah.
yeah, notebooks are so nice. Linus keeps saying that there's just no good GUI system for OpenGog, and I sent him like a screenshot of like the work you and your friend were doing. From he's like, you know, it's interesting. Maybe there's no making him happy sometimes as far as GUIs. I don't know.
Are you talking about atom space visualizers?
Yeah, yeah. The one
Yeah.
that kind of starts in the middle and it's got all the things that spread out from it, and you can click on the node, and yeah. Is that pretty new? I mean, yeah, is that visualizer new?
I actually haven't followed that very closely. There's one new, but perhaps surprisingly, I've never used one. Even though when I do see the representation of a hypergraph, it's interesting and it's informative. So
Yeah, it's a debugging tool, right? Debug to figure out why this went awry.
where I can be a good debugging tool. Right, I agree.
Well, I'm assuming like if you have an area that's completely empty, that's not supposed to be like if you. Well, I was going to ask you about the planner system that you're doing. Are you having a plan? Are you having the rules of the plan in atom space and then returning a plan that's written in atom space?
Right, exactly. So the rules are essentially they're just predictive implication, but they can be composite predictive implications, so that they can contain multi-action plans, and so they are learned, they are inferred ultimately by PLN, but there's a pattern miner that is kind of one could see as a specialized kind of PLN reasoning. And so with that we can discover plans, and once we have many plans, we can combine them to discover new plans without having to pattern mine them. So that's very efficient. But of course, the truth value we get from these plans that have been obtained by a form of temporal deduction are not as, they don't have a truth value which is as accurate as it could be if we were to say use pattern mining. But although we can actually evaluate the truth value two ways, either directly using observations and indirectly using deduction. So it's actually not
take
something
the whole plan and sort of run their truth values together as a final value, right?
Right.
Mm-hmm.
Right. So basically, the plan is being discovered, and then as of right now, it's not very flexible in the sense that depending on how the plan is being discovered, there's a particular rule that's been, well, kind of hardwiredly selected to calculate the truth value. But if it's direct evaluation, then this rule is going to go through the entire history of observations. And if it's via temporal deduction, well, then it's a more speculative sort of reasoning, but much more efficient because you don't have to go through possibly thousands of data points.
So if you're doing a temporal deduction, you want to keep its truth values kind of different than doing a different kind of deduction, right? Something
right. You're absolutely right. That's not the case as of right now. It's all mixed up. The truth value is, I mean, the way it's working is it's basically, well, whatever has the highest confidence is going to win, and we don't know where it's coming from unless we just we look at the history of inferences. But ultimately, I think you're absolutely right. There should be the knowledge in the atom space that says, well, this truth value has been obtained by this, and well, I can actually do that to some extent. But there is every time I run the rule engine, I can associate a trace atom space that would save all the inferences and how they relate to well, the premises and the conclusions, so on. But I'm not doing that at the moment.
Well, I was thinking if you really had to or wanted to, you could just create one extra node-away link to hold that secondary truth value if you needed more than just 2 dimensions. You could just add another link to it, and that link would hold the secondary, the third and fourth value that you're.
Yeah, I think you're right. That's not what we're doing, but I think you're absolutely right. It should be like basically I think that there should be a function that allows you to query the end result if you want to, but the representation of the truth value should be decomposed into its various origins.
Yeah.
I think absolutely.
Oh yeah, track back from actually all the changes. Like really, what you're getting is a whole trail. Maybe it was.
Yeah.
And that's.
And I think actually a former version of PLN that was in C++ really a long time ago, over a decade ago, actually did that.
Mhm.
Yeah.
So is MSpace going to be ported over to Meta? How's that? Is that what's going on with that?
Right. So Meta is the language to communicate with the atom space and various cognitive processes. Or you might say it's the language to represent knowledge in the atom space.
Mm-hmm.
But the architecture, the new implementation is called Hyperon. And if Alexey is still on this call, he's still here, he'll be able to provide many more details because he's actively working on that while I'm just following from a distance.
Yeah. Ben said there might be a certain phase where like the work you're doing gets ported over or something, right? For Hyperon.
Right. So what I'm doing is I'm really trying to accumulate knowledge because actually doing agent control purely via reasoning is not something that we've done a lot. We've done that a little bit, but there's a lot we have to learn. And so all this learning will be able to be ported to Hyperon. Yeah.
Yeah. So in a way there's something called inductive event calculus, which is sort of planning procedure that's really compatible with narratives, at least however you want to see them, to where what you have you have state, and state, and it says what actions do I have to get from this state, which is just planning, and so it'd be I guess I'm wondering, are you doing a little bit of that with doing state transitions with the planner?
Right. So I'm doing that. I mean, in the sense that so we have schema, we have what Ben calls cognitive schematics, where you have in some context, if you do some action, you're going to end up in another context, and so that would be this. That's how you can kind of represent jumping from a state to a state. Although we're not really talking about a complete description of a state, we're just talking about a property. And so the thing that interests me, well, the most, but not necessarily the most, but that puzzles me the most, let's say, that I feel the desire to learn about it the most is actually reasoning with temporal constraints. Because the thing is, reasoning is intractable, and so we need to have how we call that, expiry. We need to have expiries, and in order to do that rationally, you need to reason about these expiries. And so that's why I'm trying to. So I kind of have a question. How the event calculus deals with real time. I mean, measure time. Okay, this is going to happen in 2 seconds, or yeah, I did something.
So usually event calculus just converts it to a total order, and if we have something like 2 seconds, say something happens in 2 seconds, and then 60 seconds, and then in 61 seconds, it secretly converts down to 1, 2, 3. Because if you're trying to actually you preserve those, but if you're trying to somehow actually make them that far apart in reality, you don't have to do that, but you do have to sort of like say label your time steps and then insert little in-between points. So, you know, so what I do is I make sure that for every time point, there's 3 kind of like slots before, during, and after, you know, and depending on how things unify together, you know, they might overlap in time, or they might, you know, but there's only a finite number of ways things overlap, like only, like, you know, and not overlap. It's sort of like 2 to the power of 8. I mean 2 to the power of 3 at this point, at that point. So event calculus really secretly does a label over time, usually, and just converts these into like individual placeholders. And if you say that, okay, so after 3, something is always true, that's okay to say, as long as it's not so expensive it has to be 3 through 61, you know. And there's smarter ways of doing event calculus too, where you literally actually use constrained variables, like you'll use finite domains, which is where you say this integer is always bigger than that one, or this integer is always 2 away from that one. So if I'm trying to like go swimming, or say I stop swimming, how long will still be wet from the water? You know, I might say 8 seconds or 80 minutes later I'm dry, and I can make sure that by just adding those temporal constraints that I won't be dry before that, you know. And it's sort of declared, but what it's about is that maybe some of the harder parts is making sure that all those constraints are respected. And this guy, that Tim McCluskey is a guy who wrote the planner called High HTN, Hybrid HTN, Hierarchical Transition Network, Hybrid Hierarchical Transition Network. And he had this idea where he would assert all these instances and steps and only allow things to connect together in a certain way. And it turns out to be extremely fast. Where I was
right, so he would prune. So it's a mechanism to prune the inferences, right?
Right. Yeah, he didn't prolong. So what happens is everything is already grounded, and the only way things will unify is if they were grounded to unify. And so it's like runs as fast as a single line of as a single prolog query. And if you're going to do it, so it kind of automatically joins because everything's made up of 3 or 4 nodes. So if these 2 nodes are going to overlap, they're going to overlap right here, and there's no search at that point. It's just all unification. And it's just so efficient. It blows my mind. Like a lot of planners might do good for 5, maybe 7 steps. This one does good for like 58 steps. Yeah. But, yeah. You know, something about the effective event calculus of Murray Shanahan is his is actually like an interpreter, and it's sort of a weird way of thinking about it, or way of doing things. And he still gets all the constraints that you're looking for, and he interprets it as a backchain, set of backchains. But yeah, so your question is like, is it efficient? How do you do it efficiently, or is it how do you do it in general?
Yeah, I guess it's how do you do it efficiently. Yeah, it's something that I mean, obviously we want to deal with time now. We want to take advantage of scales and to easily go from one scale to another, keeping the relationship between the scales, doing extremely quick inferences, extremely short, just by jumping over large durations using the scales. And then I wonder, I mean, that's something that we're not doing at the moment, that I kind of wonder how this is done by others.
Well, a lot of times I was saying we normalize the scale into 1, 2, 3, 4, 5, even though there's like, even though the program is going to specify like, if it only specifies 15 important enough to worry about time points, like a total order of 15, then that's the maximum that, those are all labeled like 1 through 15, even though they're supposedly about a larger scale in time. And so it's not that bad if it's over a large time scale. But you're asking about real time. So, in planning, a lot of times you come up with a plan, and then 2 steps into your little steps, you have to totally start replanning because the world's changed. And what the dream of is to be able to do that with multiple, to where you don't actually have to go all the way forward with the plan. And there is a certain amount of reasoning that isn't happening sometimes in event calculus.
Yeah, so the thing I was thinking is, okay, what about the following reasoning? I'm going to do this and that, and then I'll think about it.
Mm-hmm.
And you can think about this plan because you have some self-knowledge about your ability to plan. And so, well, yeah, you can think about the incrementality of thinking.
We need to be able to represent that incrementality too. Or yeah. I think you're saying there's a small blind spot. I don't know, I can't phrase it for sure if it's there, but a certain amount of incrementality of, actually no, what if you actually, you can say there's a probability whether I can take this action, but we don't necessarily have a probability. Can we even make a plan at all or not? That we don't.
Well, we actually, you could, because if you have planned enough, then you did get some feedback about the success or failures of your past planning. So you could use that to evaluate how well you can plan, and how well you can plan in certain contexts and for certain roles and so on. So
Yeah. What I was thinking is that how if you needed to really represent, if your problem wanted to represent that reality or this learned history without somehow dragging it all along, but putting it there as a single package, as a single query, or as a precondition to something. Sometimes we don't have a clear representation, but we should. If we don't, then we should.
yeah, I'm not sure I understood what you mean by a single package.
I'm opening my web browser to wait for that package. I mean, was it a particular? Oh, there it is. Oh gosh, heck. I just found the chat box. I've been looking at the little chat thing, and usually it has a number if someone says something, and it hasn't had a number. So I've been missing Alexey's, what he was for everyone. Oh, okay. You're saying goodbye. Let's see. My gas isn't this linear perspective. Oh yeah. Oh, something I was mentioning it. I think I actually remember a program now that actually uses this probabilistic planning, where if it tries a planning action and it fails, the likelihood of it failing is at runtime. It uses it just uses a random number. One of the preconditions is a result of postconditions is a random number of whether or not it will succeed. And so people are trying to make that planner efficient, and definitely added some layers.
Well, that's kind of tied to exploitation versus exploration, it seems.
Exploration, that was the thing. Yeah, so what do you mean by that? Is that where a conditional effect stops being true just because of time?
Well, yeah, I mean, so the thing that I'm really obsessed about is, okay, you can have a strategy to, okay, for instance, balance exploitation and exploration, given that you have a limited amount of time to think about it. But how do you justify it rationally? How do you justify everything that you do under time constraints, given that, I mean, can you go all the way down, or at some point there are things that you just, I mean, even if you would be able to justify them in principle, you know that you won't be able to justify them in practice, because that would require a computational power that you don't have. And I guess that's the practical reality of it. And then you're just trying to minimize the amount of error that you do in practice compared to the idealized.
Well, you know,
Yeah.
like kind of the question that it bothers me about a lot of planning and planning community, or just what software is out there. I should secretly be able to put in the rules of chess into a planner, an off-the-shelf planner, and have a chess AI level AI. I mean, it sounds like a crazy ask, but at least the planning community says that's a crazy ask. But it's secretly weird that we don't have something that will make everything that would become efficient in those circumstances, even if it had to take, like, you know, a day or so before you could ever run anything on it.
I was thinking about this problem of exploring the space exploration, and if it's biased, or if there is some hard-coded rules which are driving the exploration, instead of going with the most simple type of random type of exploration policy. And more that I think about it, it more seems to be that it's just a question of trade-offs. Because if we have a system which has limited computational capabilities, then we need to think about smart ways, some kind of optimization of exploratory processes. But what would be the alternative? What if we say, no, we are just sticking with the completely problem-agnostic random type of exploration policy, but we somehow organize huge computational resources that are increasing by the day on the planet, and then just get to the answers to the crucial questions. We have a lot of these questions within the AGI community, and then these will be solved. So it's the stupidest possible approach, but with a good organizational, good global organization, maybe we have a chance to further some of the things that we are trying to accomplish. So it's just the trade-offs. You don't have computational, you need to optimize. But what if we optimize in a different way, by a community type of approach, communal?
So at one point I was thinking you were just talking about sharing computational resources, but you're also talking about sharing algorithmic solvers.
I was thinking to have the simplest possible algorithm for exploration, basically like a random motion type. So you're just exploring whatever you need without any bias and nothing. But apply a huge amount of resources that are available on the planet. And I believe that also decentralization will be a very important aspect of this kind of approach. But still, my hope is that we would get some kind of answers, because we can pose certain questions to system like that. For example, we can simulate. Okay, let's try various type of. So the problem will become, how can we just describe in very general terms what we are interested in searching for, and then hopefully this highly decentralized computational system will explore these things, and one of the nodes will hit it. And then, of course, it will spread. The solution will spread to all other nodes. And again, if this spreading is complete, because this is variable, let's say, very variable theorem, you can look at it like a constructive type of approach. Then the next step will be closer. So in a way, it won't be exponentially harder, but it will need very good coordination of many of computational resources which are available on the planet. Probably some economics will be part of that. That's why I'm thinking, like a blockchain type of thing. But and there are, I believe, certain initiatives within the Singularity Net mega project which also are dealing with sharing computational resources and stuff. But this is completely, maybe it sounds strange, but I'm trying to take a very simple, stupid approach, but with different angle to it. Just that.
Mm-hmm. Yeah. Are there actually even? I mean, I don't know. Are there new computational sharings that I don't know, platforms out there? Like, I've been doing so much on my own machine, I don't even know what is out there, like what's missing, really. I mean, I definitely know like some sort of search organization optimizer is probably not out there, you know, that would make people's resources share in the most intelligent way. But I only know what we have for sharing those resources.
Well, I think NewNet is kind of trying to fulfill that goal. Like,
So with NewNet, I mean, I don't know about NewNet, but I've just always wondered if there's like, if people that share the resources could earn a token.
Right, exactly. I think that's the point.
Mm-hmm. Yeah, so instead of like being worried about going and buying tokens, you'd be being able to basically, you're mining by sharing your resources, right?
Exactly. Yeah.
You're mining useful theorems for whatever questions or problems community is interested in. But I see the current approach is that you have some tokens, and then you are paying for some distributed computational resources that you are using on other people's machines. But this would be like a difference. So the reward, like a mining reward, would actually be something valuable, not just some kind of hash with very good properties. So kind of a nonce which, when hash is results in some very good properties, like what is used for the proof of work in Bitcoin, but something which is very relevant to a question that this community is willing to explore. And then the rewards will be mined theorems or actually synthesized programs for very difficult problems and difficult questions that we have within this AGI community.
Mm-hmm. In a way, you know what Tau Chain does, right? Or you've heard of Tau Chain? Supposedly it's just it's like it's a distributed way of doing queries where, like, say, only the easiest way is from a high level. Like, someone wants to know what team is going to play some other team a week from now. They put the query out on the network, and then somewhere out there in the networks they answer them. Is that similar? I accept it would be like much harder problems.
It has some aspects that are useful for this the view that I have, but this is also more of a I mean, if the mined result is something that other nodes can verify by simple, short, and very efficient computational process, then it could look like it's what you need. Yeah. So it's difficult to find solution, but it's very easy to verify that the solution is actually correct.
To what part? I missed that.
So it's very hard to find answer to a question. For example, let me make it concrete. What are the issues, or at least challenges, that we are dealing with when we want to create AGI system? So we have some of the descriptions and some constraints which are collected so far, which we were collected so far. And then if we codify this as some kind of a simple program which just checks, like a check. I know that it is not as straightforward as that. Sometimes you cannot code what you want to see, just a simple check. But if it is possible, and for some of the challenges that we have within the AI community, we can definitely say, yeah, if I have infinite, let's put it like this: if I have an infinite computational resources, what kind of answers can I get in that case? And what kind of questions should I ask if that's true, if we have access to that? And then we can say, okay, because we do not have access to the infinite computational resources, but we can say, okay, we have a lot of these computational resources which are distributed in various places. And then we can say, okay, let's see if we can ask maybe simpler questions, and then all these nodes will compete to solve maybe parts of that problem. So it's very, very important to have a standardized protocol or languages or ways to communicate between these, so that all these nodes can share solutions to sub-problems. That's why I was thinking about the constructive, like a mathematical approach where you're constructing the theorems can also have the equivalent programs in some formalisms, and then we can say, okay, so these are like a subroutines within a larger synthesized program, and we can say, okay, what is this program? Because we are all programming, like we are trying to create artificial general intelligence systems by developing software, and we can say, okay, so what is this? Maybe just one module within this large AJ system, which is very important, and we need it, but we don't have it now. But we can say, okay, can all these distributed resources compete to solve this? To solve it to synthesize the modules of this AJ system, and finally to integrate everything within this AJ system. But the solutions or sub problems which are accepted by most of the nodes in this network are actually rewarded, and rewarded by with some kind of tokens or coins, whatever. So it is some kind of a proof of work, but it is based on what the community actually wants to accomplish, and this will be So it's not agnostic to computation, but it's very somebody has to define this. And of course, I can also see the future of this distribution of value of this kind of successfully mined successful problems and general artificial intelligence programs, because you can apply those programs to various problems around the world and get some reward. It doesn't have to be monetary, but by some kind of value tracking economic system or network overlay above all these distributed computational resources. So these are some of the components that I'm thinking about. Most of I just saw that there is a lot of things which are agnostic to computation. You can pay, you can say, okay, so somebody can you run this software and I will pay you this much. But if we somehow add additional, yes, but we need somehow to communicate so that all these nodes can communicate not just the code that they need to and the reward that they will have by executing this code, but somehow even the components of this code and the purpose why they are being executed, so that it is more involved than current type of, at least what I saw. Probably there is a lot of research in this domain as well. But these are some of the directions that I would like to see moving forward, and that can help us, because it will be community effort. Yeah, some node gets